So welcome everybody to this hands-on session in Fsharp programming. So this presentation is divided into two parts. In order for you to get a little bit of a background into sort of basics of Fsharp, I'm going to give you a whirlwind presentation of Fsharp. Some ideas how the code looks, what it is, and then we're going to dig into writing a real client-server web app and see how that goes. Don't try to understand everything. And what we're going to do today is pretty advanced stuff. Seriously, pretty advanced stuff. We're going to do a reactive single-page application with a server backend, which it can communicate with. And there's going to be a lot of libraries, and there's going to be a lot of stuff going on. So don't try to understand everything. What I really want to convey to you is how things work out when you do things in a functional setting with Fsharp and also with WebSharper, which I will demonstrate to you. So, Fsharp. Fsharp is a strongly typed, functional-first, object-oriented language. And by strongly typed, this is not like strongly typed like C# or Java. When you write Fsharp code, you seldom see any type signatures at all. Everything you write is generic by default. And working with generics in Fsharp is so trivial that you don't think about it. The compiler it looks like it's dynamically typed. It looks like it's a scripting language most of the time. The compiler automatically fills in the types for you and generates the types for you. And the other thing is, all the data is immutable. We have to be very explicit about what is a variable and what is not. Well, we don't have to say anything for what is not, but when we need a variable, we have to be very explicit about it. Let is the most important keyword in Fsharp. It's all over the place. And let does one thing and one thing only, although it looks like it might be doing many things. It binds a name to an expression. So here we say let x equals 42. It binds now the value of 42 to x. And since x is immutable, 42 and x can be used interchangeably. There's no difference. X is a definition of 42. We can also say let foo is equal to sign 3.414 blah blah blah. We could call a function, so this would be a function call. And we just bind the result to I shouldn't say variable, to a value, a named value. But let is also used for function definitions. And I've written up two absolutely totally equivalent ways of defining functions in Fsharp. The first one says let bar equals, and then there's a lambda function. How many of you know lambda functions? Yes, most of you. Perfect. So that's an anonymous function. It doesn't have a name. But by using let, I can bind an anonymous function to a name, and suddenly it's not anonymous anymore. So I can create the function that way. The other way I can create the function is that I say let bar x equals x plus 1, which is sort of the result of lambda. That's syntactic sugar. So when I write that, it's actually translated internally into the compiler to a lambda expression. But this is the way we normally do it because it's compact. It's less typing, it's less characters. It's easier to read. But it's really just binding a lambda function to a name. Lists and tuples. Tuples are immutable and heterogeneous. So you can say, well, parentheses 1, 2, 3. Or you can say 1, hello. Lists, on the other hand, are immutable also, but homogeneous. So you can only have the same type in a list. So you can't say 1, 2, foo. If it's integers, everything has to be integers. And there's a whole bunch of list operations and list functions that we can use. So we can bind a list to a name, and we can concatenate two lists with the operators. Then we have, that would be foobar. And then we can call the generic sequence.length function on it, and we would get the answer 4. So one thing that's distinct about Fsharp, and takes a little bit getting used to, is that there are no parentheses around function calls. So I had, here I said sign parentheses 3.14. That was just to make you feel comfortable. The normal way of writing it in Fsharp way would be sign 3.14, no parentheses. And one thing to watch out for is, especially when you have functions taking 2 arguments, so fxy is a different thing from x, y. fxy is a function taking 2 arguments, whereas f parentheses x, y is a function taking 1 argument, which is a tuple. So that's a different thing. A higher order function, or a HOF, is a function which takes functions as arguments and or possibly returns a new function. They're nothing to be afraid of, and you've all probably used them. How many of you know map? Yeah? So that's a higher order function. Map takes a function, applies it to something. Another thing which you don't really find in non-functional languages is partial application. So suppose now I have a function f, define a function f of 2 arguments, x plus y. I can call it with just 1 argument, the x, f5. I can bind that to a new name if I like. And now I can call g with a value of 37, and the result will be 42. Huh? So if you don't give enough arguments to a function, what you will get back is a new function. So f5 produces a new function, and it stores the f internally inside this with the x with the value of 5. So it remembers the 5. And this is used extensively in a lot of functional programming. And it's sort of confusing in the beginning, but it's a very powerful thing. Now, map. We're going to see a lot of maps today. Map applies, there's an n missing, given as a suitable function to some container type. Well, typically the container type would be a list or a string, which is basically a list. And it takes the function that you give it, and it applies it to each and every element of the list. So what you get out is a new list where the function has been applied. So if I would say map, and then I use a lambda function there, fun x to x plus 1 to the list, I would get out 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Or I could say map cosine to that list. But map is kind of special. There are a lot of types of kinds of containers. And one of them is the option type, which I won't go into any details, but the option type can either contain a value or it doesn't contain a value. And it's a container type, and it has a map defined. So I can map a string to a container type, which is now containing some value 42, and it would produce the value of some string 42 for me. And we're going to see this. I'm mentioning this because we're going to see this when talking about reactive programming and transforming observables. We've also got functions like filter, which removes elements from a sequence. So you give it a predicate. So here's a check if the number is larger than 0, and you run this on that list, and you would only get the ones larger than 0, which would be 1 and 42. Oops. So returning to map and sequences. Map is the primary way of looping in functional programming. This is the most used way of looping. And why is it better than a loop? When you read for x in blah blah, you read that line in your code. What do you know about the loop at that stage? Not really much. You have no idea what the output is going to be. Is it going to be a number coming out of that operation? Is it going to be another list? Is it what? You have no idea. But when you read map and a list, you know that map is going to guaranteed produce a list of the same length as the list that you put in. When you read filter, which is also a kind of a loop, you know for sure that when you read filter, you already know what it's going to do to the list, and you know that what you will get back is a list of length n or less. And then there's the final variant, fold, which is very general, which allows you to loop in very general ways of list. And I won't really talk much about it, but it updates an accumulator, so you can actually implement both filter and map using the fold, and a lot of other things. You're going to implement the vector sum and so on and so on. We're going to be using a tool today which is called WebSharper. WebSharper is a Fsharp to JavaScript compiler. It allows us to write Fsharp code and compile it directly to JavaScript, which we can run in a browser. WebSharper comes with a whole set of nice libraries for reactive programming, for a whole bunch of things. And one of the things that we're going to be looking at and using extensively is so-called combinators. And the combinator is typically a set of functions designed to be combined arbitrarily, usually arbitrarily, within the sort of their domain. And these are used to define so-called embedded domain-specific languages. So inside of Fsharp, we can define our little own programming language to express some special aspect of something. So we're going to use some HTML combinators today. I have two examples here. There's a function called h1, which takes a sequence of a type doc, which we don't have to worry about, and produces a doc. And there's another version of it, h1attr, which takes a sequence of attributes and a sequence of docs and produces a doc. And what we can use these for is this thing here, h1. You probably already guessed it. When compiled into JavaScript and run in the browser, it will produce an h1 header1 tag. But you don't have to specify the closing tags. So, and when you use these, instead of writing HTML by hand, you actually get the benefit of the compiler type checking things for you. And you never have to worry about ending tags or suddenly getting the tags in the wrong order, so you close things before you should, and because that can't happen. It's a compile time error. So here's an example of it. There I have the function div. It takes a sequence, a list, and that list contains a h1, which again takes a list. You see, it always takes a sequence of stuff. And there's a function text, which will turn a string into a doc so that it satisfies the type. And then finally, a little bit about WebSharper reactive programming. We're going to use it in a very simple way, but there's a function called VarCreate, which creates a reactive variable. We can update it by saying x.value and use this sort of pointy in arrow to give it a new value. We can observe it using x.view, and those views can be mapped so to transform into new views. And this is very powerful, as you will see. So this map takes a function and it applies it to the view, and we get a new view, which we can then show on the screen. And all my examples and everything is on my GitHub page. Right. Let's get to it. Did you get it? Yep. Close that. I'm going to start by just showing you how to set up when you install the Fsharp tools and install the WebSharper templates into Visual Studio. Just going to open a new Visual Studio. I'm going to cheat a little bit to speed things up, but I can choose New Project. And if you've installed the WebSharper packages, you get WebSharper templates. And you can do a client-server application. And we'll just say click, OK. Did I click OK? No. And Visual Studio will bootstrap a project for us. And now you will get a stub client-server, reactive client-server application that you can compile and run and look at. I decided not to actually use this stub project for a number of reasons. It's way too complicated to start with, in my opinion. So I've cheated. So I created my own where I stripped off most of the unnecessary stuff and added packet support instead of running NuGet directly, and a little bit of sort of making it more convenient to work with. This is taking forever. It's probably trying to access the web or something. Right. So what we get here is a couple of Fsharper files, one called remoting, client, main, and an HTML file. And everything below that is just stuff you don't have to touch, ever. That's it, more or less. It's just standard ASP.NET hooks and blah, blah. It's just has to be there. So it's, in essence, it's 3 files that we have to care about. Now, let me close this one. And look at the main file. We're going to go through this very quickly, and then we're not going to look at the main ever again. Main is pretty much, regardless of the project, is more or less the same every time. Define a namespace for this module. We import some packages, some namespaces and modules. And we define a type. This is a special type for very common in functional languages. It's called a discriminate union. I won't go into the details, but it's a sort of it's a union type where it's either this or that. And here we can define some endpoints and give them sort of the using an attribute. We can say what the address to that endpoint should be. The whole point of this is that in this framework, everything is parameterized over this endpoint type, which means that all links, all endpoints, everything we create always takes this endpoint type, which means that we suddenly have type-safe links. We cannot create in WebSharper a web page which is with dangling links in it, unless we hard code in some dangling link, but that would be defeating the purpose of it. And you can't really point to stuff that that you haven't defined. Then here's a little templating module. It uses something called a type provider. I'll show you this. This is a very powerful thing. We're going to use a type provider for SQL later. But the type provider is something that reads some definition and generates a type for it. And since it's a type, it has some strict rules, which means that you gain a lot of type safety. So here I'm reading this main.html file, which we can look at. It's pretty much a very stripped down thing. Blah, 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 header, there's a placeholder title. And then blah, blah, bootstrap, div class container, div data replace body, another variable that we can change. And then there's another called scripts, which we don't touch. So if I go back to my visual, oops, go back to the right file, I'll show you what but this is what's happening. I define a templating function which will take a title and a body. And what it will do is fill in the title in the template and the body in the template. And gobbledygook, and then there's title and body. Now, what happens if I would have a more complicated template and I would forget to set one of the things? I have a type-safe template. It's a compile time error not to fill in all the stuff in the template, which is pretty neat. And then here's my website definition, and there's a function called homepage. It takes a context which I don't use. It calls the templating function with the string home, and it defines the body. And here you can see the body consists of a sequence of docs. And here's the H1 combinator. There's a special little thing here, which we'll talk about later. This is actually will load in a single-page application, which we have defined in this client part. So this bit here gets compiled to JavaScript. And here's a silly little about page and so on. And here's the type-safe routing to the main page and to the about page, and that's it. So here you can just add your routes and be done with it. And there's a whole lot more thing you can do with it, but it's not really interesting in this context. So that's basically all I have to say about that. Now, client FS. Again, namespacing. The thing with the client here is that there's a little attribute, JavaScript, on top of the module. You can put it on functions as well, which tells the compiler that this is to be translated to JavaScript. And I define a function. It takes no arguments. I have to use this parentheses to say that it takes a sort of a null argument, a nothing argument. I create a reactive variable. I call it message. Its initial value is just a string, empty string. And then Fsharp has something called workflows. And here I'm using the async workflow. And async is quite nice because it allows you to work with asynchronous computations as if they were not. So you can build up all these complicated asynchronous things. You can compose them. You can do all kinds of nice things with them. And in the end, at some point, you're going to be running async start, which is going to actually start off this whole thing. And it's going to run, and you don't really know when it's going to finish. And again, I add a div. And div, if you remember, takes a sequence of documents. And here again, H1 produces documents. It takes a sequence of documents, produces documents, and so on. And then I use this text view, and I listen on the message view. Now, here's an interesting thing. Inside this async block, I call server hello world. And you can see this is just the normal Fsharp function call. There's nothing special to it. It will return a value, and I will set the value of this message to the value of this function. So what will happen here is we create this thing. This will fire, will happen, it will run, it will contact the server, it will run a server function for us. And whenever the server has returned a value, we will set it to this reactive, set the reactive variable to that, and here we will show it. And that's it. Now, how is this defined? Well, here's the server module. Here's the hello world function. It's tagged with the attribute RPC, which tells the compiler that this should be set up for remote procedure calls. And that's everything we have to do to take care of communication. It uses XML, RPC, AJAX, something in the background. But it's really not our problem how it's done. And it returns asynchronous, and it returns an asynchronous computation returning the string hello world. So now we can compile and run this whole thing. And you will see, first it will compile the Fsharp code to a DLL, and then it will run and then it will run the WebSharper to generate the JavaScript, and it will nicely put everything together. And now we need to get my web browser here. And to our not so big surprise, it produced to do, which was in the main.fs file. To be written was in the client, and hello world came from the server. So now we have 3 levels of things. So now we've written, this is a full-fledged HTML5 reactive web application. And it's, what? 30 lines of code. Huh? It's not too bad. So now we can actually take this and start looking at, okay, what can we do? Let's go back. So there's the to-do text. There's the to be written. And there's the message view, which came from the server. Yes? You don't want to know. Not today. It has to do with the fact that the server is returning an async value, and we want to strip off the async bit, do the computation, and sort of bind the result, and rather than the computation. Technical. Right. So let's see if we can do something with this. So I'm not going to touch main again. But what we can do is we can say, well, okay, throw out this bit here. We don't need that. Yes. Create a new reactive variable. Okay. I can remove this. I can actually remove the whole thing there. I can do. I'm going to create an input field. Let's see. I'll check this type signature. I think it was like this. No, like this. Oh, I have to look at my cheat sheet. Should doc input. That should be right. Oh, yeah, that was supposed to be a string, of course. It should contain an empty string. Now, and that MSG there is going to be to-do text. Okay. So now no server calls. Now we're going to compile this and see what happens. Where's the input? Hello. Ah, silly me. I forgot a very important thing. No, I didn't. Just the div. I wonder if this is because I'm not. Let's see if it's still waiting for the. Yeah, excellent. Net. my cache has expired. So now it suddenly doesn't have jQuery and friends. I think I need internet. Where's the mouse pointer? Does anybody have okay, here's an exile 4G. Do you have the password for? Oh, okay. Hi. Yeah.
Capital E exile. E-I-L-E.
Yeah. Let's see. All right. Let's see if we can get this thing to run. Where's my mouse pointer? There we go. Ha. There we go. So, now we've got an input box. And look what happens. You see, reactive. Not so impressive, but you know, it's a start. So what happens here is the following. I create a reactive variable, I couple it to the input box, and as soon as the input box changes in any way, it will update the reactive variable, and then using this text view, which takes a view containing a string, you can look at the type signature, it says view of a string producing a doc. It will just update that immediately. Now, this is very good, but it's sort of, if we're going to call a server and do stuff with a server, it's not going to be very convenient, because every time we type in a single character, it's going to fire a call to the server, and that's going to be pretty bad. So there are ways we can control that. We can create a, let's call it, I will call it tag it. We can use a submitter. Oops. And then we need to write it submitter in the right way. So there we go. Yes. Right. So a submitter is something which is listening, is observing. It takes the view, which is observing a reactive variable. You give it an initial value, and it will update itself with the latest value of the reactive variable it's observing, but it won't change itself until we fire it with the trigger command. So we can do this. So we can add a, oops, right spot, stop. So we can go down here and we can add a, well, we could put in a BR to start with, which is just a break. And then we can do a paragraph if we like. And then we can add a doc button. Added some text. We can say tag. No. Yes. And then we can add a text view below it. Just had a break. And then we can say doc text view tag it dot view. All right. Now we can try to recompile the thing and restart it. Where's my hello? There we go. And try this example. Okay. Foo. Tag, and it comes. Any questions so far? So now we can go back and we can look at this and say, okay, that was interesting. But I can do, actually, I can do better than this because I could, oh yeah, this is now a text view. Oh, okay, no, I won't bother. Because we could start using map on the tag it view and we could start doing things like boldface or styling things and all kinds of nice, neat things. All right. So I want to show you, we're going to build a very, very quickly now, time is running fast, build a little to-do app. So I prepared it, and I'll have all the code examples on my GitHub as well. So I'm going to just scrap this bit here, and I'm going to copy some code, and we're going to go through it, and because this is going to save me a lot of typing, and as you can see, I'm not very good at typing. I do a lot of mistakes. Okay. So I have some snippets here. Let's see if we can get back to this window. Yes, there we go. All right. So the first thing we're going to add is a reactive list. It's exactly like a reactive variable, except it's sort of a list, dictionary list type of container. And when you change a single element of that, you can have things respond to that single change instead of sort of redoing everything. So it's a sort of efficiency. You could just have a reactive variable and put the list inside of it. But then every time you would change a little tiny piece in a huge list, then it would trigger all hell, would break loose, and it wouldn't be very efficient. So here we use a reactive list instead of a reactive variable. Here I define a private, module private variable. Since this is sort of a dictionary type of thing, this create thing takes a function which is just putting the sort of dictionary key, which I would just take to be an integer, and here's the integer. And this is going to be the state of how many elements have we put in the list, and it's just going to keep ever increasing this ID thing here. I define a little private function called add to items. It takes a single argument, s. As you can see, no types anywhere. But it will receive a string, and it will figure out that it's a string. It will increment the item ID, and it will add the item ID and the string as a tuple to the reactive list. Here's the to-do text. There's the submitter we looked at. And then here's a new definition to do tagged, and it's calling a special version of map on the value inside the tag it thing. So when we fire the submitter and we get the text from the input box into this thing will fire, and now it will look at the stuff that was inside the input box. And now we're going to do matching. And we'll look at if the value inside the input box is empty string, well, we're going to return a asynchronous empty string computation. If it's not, return a server function, which I haven't really defined yet. So I should probably copy that into server so we get this thing to compile. It's going to be a very simple function. Right, back to Visual Studio. I'll go into remoting here. Save that. Go back to client. And now it's not red anymore. Right. So what happens now is that we will have a workflow where this gets updated instantaneously from the input box. Then we put the submitter on to delay the propagation of the signal until we press a button with the label tag. As that value, this view changes, it will actually trigger this thing here through this map, which will call a server function, which will return a value which then gets stored inside this new value. So this will be the server response inside this thing. So here's my submit. Here's another trigger to submit things. And that will be created on this one triggering. Okay? So now we have from this one little sort of thing happening here, and this server call, when it's done, this gets updated. And then we're going to have this other submitter is going to be listening on that change again. And when that gets triggered, it will just have a function that will produce no output, but will call this add item to the reactive list. And then we're going to define the document itself. Start with a div. There's the input for the text. There's the tag button. We add a text view, horizontal rule. Then we're going to make a preview thing so we can preview what came out for the server. And then we have this add, which will trigger this other submitter, which will add it to the to-do list. And then we will have a table which takes the to-do list view. So it's now observing the list. And it is weird function bind sequence cached, which take a function which will generate a table row with table data for every row in the reactive list. And that's it. So now we can run this example and see what happens. So the first part you've already seen. So that's foo bar, you see? And now when I press tag, it will check whether that's an empty string inside the input box. If it's not, it will send it to the server, and the server will add the date time string to it and return it back to my web browser, and it will put it in the preview window. So now I can look at it and say, oh, yeah, there was an S too much. Yeah. Oh, tag. Yes, that's good. And now as I press add, it ends up in my reactive list. Of course, there's, there we go. I can press add many times. And you see how the ID gets increased every time. And so I can add it as many times as I like, which is probably not really good for a proper to-do list, but right. So now we can write our little to-do items and add them. So let's see. Let's style this up a little bit. This is not really pretty to look at. let's see what we have here. Yeah, okay. Right, so one of the things is, of course, a to-do list. I don't really have a way of removing anything. So let's just quickly add some removal function. Still got 15 minutes. So we can go back to Visual Studio. And I'm going to add a new function up here. Oh, of course. RM to do item takes an ID, and it just calls a function of the reactive list remove by key ID, and that's it. Done. And then we can go back to here, and I'm just going to nick one or two lines of code here. We can go back down to here. Oh, that got indented completely. Right. Did I miss something here? There's the button. Aha. Okay. Oh, crapster. So that should fix it. So you saw, as soon as you miss a closing bracket or something, it's a compile time error, and Visual Studio will tell you immediately. So let's see how that works. Tag it. Add it. Ah, nice. Now I have a little X there. So now I can add this a number of times, and I can click, 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 and we can remove them again. And add and remove. And it's all happening inside the browser, of course. There's no server communication going on. So what you probably saw now is, okay, fine, this was an improvement. But as soon as I open it, I have lost all my work. So that's the last 12 minutes of this presentation. We're going to add persistence. We're going to access a database. I already set up a very simple database for the purpose. So that's the last piece. No. I had one more surprise for you before doing that. We can do this very quickly. I think I'm just going to copy. Go to Visual Studio. Just to be fast, because this isn't looking too good. It's pretty ugly. So let's make it look a little bit nicer, and I can show you some cool things you can do with map. Why map is such a wonderful friend. So let's take that. So now we're going to add some bootstrap styling to the tables and to everything to make it sort of look nice. I added a function up here, which I call special. And the purpose of this special function is it takes a string, and it will match the string and see if it starts with a particular string, and it will produce another string. And these happen to be bootstrap class strings, so that I can use this function to dynamically set the bootstrap class of things. And nothing has really changed here. We go da, da, da. The only thing is now suddenly I have added this class btn. If you're familiar with Bootstrap, you probably know these things. I added a jumbotron and a button primary here and a little bit of table with an attribute class and a glyph to the, instead of having an X and so on. So we save and we run. Right. So now you can see it looks more professional now, bootstrapped. So again, foo, tag it. Hey, it came up inside the jumbotron there, and now my add button has a nice color to it. So we can add. Well, we can add it a couple of times, and we get a nice minus. And remove it. So look what happens now as I start typing. For example, NB. Hey, you see? And we add it. Yes? Now we can instead say, done. Oh, green. So how would you do that? Let's go back and have a look. Here, as I type, so this is the thing which is listening on the direct raw input from as I type. Instead of giving it a class, I give it a class din, which is a dynamic class. And now I can take the raw text from the input box, observe it through the view, and call map, and apply the function special to it, which will then generate a new view for me, the whole thing, where the class attribute is set to the text from this function. So now I have suddenly a way of dynamically, depending on a reactive variable, change how things look. And that's pretty nice. Right. Persistence. Go to the final version of this. Very little is going to change in my client app. The only thing I have to do is I have to go to the server and add a small amount of code there. We're going to go through it very quickly. Let's see if I can go back to find my mouse pointer. There it is. And we can go to. I should stop these things so we can get actually a full screen of things. Right. Paste it in. Let's go up here. Oh yeah, now I have them twice. I'm just going to remove it. There we go. So they're the two first, the original functions. I'm going to be using, Fsharp has something wonderful called a type provider. I already mentioned them. And now you're going to see the SQL type provider. I can't go into the details about this, but it's really a fantastic thing. I create a new type which I call DB, and I call this SQL data connection. I give it a data string connection to, in this case, Microsoft SQL Server Express, saying that the initial catalog should be that, and blah, 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 and it should use Windows authentication. And what it will give back to me is a type where I can use IntelliSense to access all the tables and all the fields and everything of this database, like if it was a normal record type, which is quite nice. And you actually get type safety for your database. So this is a little bit like entity framework, but on steroids. And it's checked, every time you compile, it's checked against the database schema. So you're never, ever out of sync with your database schema, which is a good thing. Because I don't know how many of you have ever experienced that, well, the database schema changed, but your ORM didn't, and things are not just working. And it's just a tiny little change somewhere. So it's horrible. Here I define a little proxy type. Technical things, I don't want to go into the details. It has to do with the JavaScript translation. This is how you define record types in Fsharp. And in fact, this is almost identical to a class definition in Fsharp. So it has two fields, an ID and a string. So let's look quickly at what I added for persistence. I created a database connection up there. Now I say get to do items. I want to get everything from the database. Well, I get the data context out of the type provider. And then I say all the items are, and then there's another computation expression, query. We already seen async. Query is for link expressions. So here I can do all kinds of cool link things. So I say for x in db item do select x. That will return me a sequence. I convert it, I use the pipe operator. So the output of that goes into this function of sequence function of the array module, turns the sequence into a proper array. And then I say array map, and I give it a lambda function, and I convert it into this to-do item. And I then say async return items. There's a similar one for add to-do items. Get the data context. I create a new item out of it. I say insert it on submit. I submit the changes, and I return the ID. And there's a corresponding one for remove, where I can say for x in item, select the elements where ID equals ID, and delete all on submit and return nothing. And that's it. So that's my database backend. Now we can go back to the client. And it's actually going to require absolutely minimal modifications. I think I forgot to copy one function there. Yes. So here I create a function, I call it init to do. I didn't save that one. Right. So here's my initialize my to-do list. It creates an async computation. It calls server get to do items, which will then return me an array of to do items. I take those items and I put them into array iterate. Iterate is like map, except it produces nothing. Because the only thing I want to do is go over all the elements and add them to the list. So I call to-do list add for each and every element. That's it. And then I run the async computation. So now we can go look at this thing here. Now we don't need the this line anymore. Instead, I'm going to call the server. Let bang ID equals. Yeah, that's strict. Dot add to do item S, which is a string I pass it. Oh, sorry, it's already there. ID. And then let's just say async. And then we pipe the whole thing into async start. And similarly for this thing here, we should just go async. And we're going to add the code to it. Server RM to do item ID, and that should be server RM to do ID. Actually, I can do it in a different way. So this is yeah. Oh, there's a return too many. So that should be fine now. Yes. And that's it. That's it. That's what I have to change now in my server, and I can run it and see how this works. Oh, I forgot one little thing, of course. I, of course, need to initialize everything. Init to do. Voila. Replay. And what you see now, it came up already with a lot of to-do items that I had, and they're from yesterday when I was playing around with this. So, yes, so now we can add hello, tag it. And notice, by the way, oh, okay, now the add button is there. But I actually had the add button appears only when I have entered text, but it doesn't go away, so I haven't completely. So you can't add before you. So now there's this last line that says foo blah, and now I can do a hard reload of this page, and it comes back. I should probably not have done a hard reload. Now I have to do bootstrap and jQuery and all these tons of code that needs to be downloaded. Hey, there we go. Yes, you can see it's persistent. There it is, the last line. So here's a persistent, simple, reactive, single-page, back-end backed to-do application in, if you count it, and it's written like idiomatic Fsharp, WebSharper code. The whole thing, including all the open, include namespace statements, everything is under the 85 lines. And when you start doing real applications using this, you actually, since all of these combinators for generating web pages, they're all just functions, and it's so easy to manipulate functions. You can actually start doing things where you are actually generating the stuff programmatically for the stuff that then gets rendered on the screen. As I did with this list, so I generate the list, which is, I mean, also what you do directly in JavaScript, of course, with templating things. Yes, any questions? clear as ink. Good.
Does any HTML coding involve in this? Like, can designer work on HTML for the beautification of the application?
Yeah, so that's basically what you use the templating for. So if you're working with designers typically and they want to do things, then you can use the templating. I personally, when I do things, I keep the template. Well, you don't even have to use the template. So most of the time I don't, because I don't need it. I just generate everything on the fly. I just write the function which generates the sort of template for me, and that's it. But working with people who don't really want to dig into Fsharp code, and if you don't want to have to recompile every time you want to change the layout of things, then using the template system is very good for that. If that was your question, yeah. Yes. Sorry?
This was converted to JavaScript, right? The JavaScript code was converted, right?
Yeah.
So can you show me the source in the browser?
I can. You're not going to be happy. So let's see. Okay. So I can just take this other window, which is Visual Studio Code, where I have my snippets. And we can look at, so when you compile it, it will generate content and the scripts directory. So we can go into the scripts. And here's the devday.js, and it also generates a minified version. But here's the JavaScript that gets generated by the compiler. I'm going to close the Explorer. Now, it's not too bad. It's 178 lines. So it's actually, you can see there's my alert danger stuff, but it's not beautiful. There is actually a different compiler called Fable, which will produce a lot more human readable and nicer JavaScript. But then it doesn't really integrate with this WebSharper whole framework thing.
The jQuery dependency and the bootstrap injection, the script reference we have cited?
So, sorry,
the jQuery and the bootstrap script reference where it was.
So if we go back, look. So this is a little bit of half the story. This is what the compiler generated, but of course all of this is backed up by downloading the jQuery, and you can see here's a whole bunch of things. So what you end up with is really, ooh, no, that's not too bad. But if you sum everything up that you have to sort of, in order to get this to run, I think you're going to probably end up at 100,000 lines of JavaScript or something ridiculous. I don't know, I've never counted it. So there's a lot of JavaScript, but of course, it gets cached. And when you do, so what we do a lot of is actually to take this and use PhoneGap and Cordova, and there are PhoneGap modules for WebSharper, making it really easy to plug in and work with Cordova plugins and so on, and then you just package everything up and with Cordova, and it's there. And usually for those things we also add Bootstrap and jQuery, and everything is packaged with it instead of using CDN. Sorry,
Is this entire deployment 100% independent from the .NET runtime?
There's no the server side is running on. In this case, it's running on top of ASP. But you can use other backends. There's one called Warp and one called Swave, and so. But those are dependent on .NET. But those are running on the server.
What about deploying this? Do you recommend deploying this kind of a implementation in a Linux-based operating system using something like Mono?
Yeah, works.
Is it feasible at
yes,
the production level?
It is. And now and what's really nice is, of course, .NET Core and the developments around .NET Core. But I prefer Linux. The previous version of Windows I used was Windows 95, before I changed my job. I was working for 20 years at the university. So I used Windows 95, and then I became a Linux user. And apart for a couple of few dark years on Mac, I was a Linux user for almost 25 years. And now I switched and I'm working in a Microsoft company and I'm running Windows 10 and I'm getting desperate. I can't get things to work, but that's because my brain is somewhat probably hurt by working with Linux for too long time. So I do most of my stuff on Linux actually. Yeah, but they keep improving it, so it's pretty good. And one thing, Xamarin, if any of you guys work with Xamarin? No? Xamarin has from the start supported Fsharp. So it has been a sort of a, so Xamarin is fully supporting Fsharp, and Xamarin Studio has really good Fsharp support in it as well. And that's what I usually use that and Visual Studio Code under Linux for developing it. So there's quite nice tooling available. The only things that I usually find problematic is when you use .NET and you use very sort of Microsoft-centric things and stuff that needs Windows authentication or connections to SQL Server. But SQL Server 2016 will run on Linux. I saw a demonstration. They took a backup of from SQL Manager in Windows and got the file, SCP'd it over to a Linux box and fired it up in SQL Server running on Linux. So that's pretty nice.
That is, suppose you use something like OLEDB.
Yeah, and there's for Oracle, and there's for MySQL, and there's for SQLite, and there's for a whole bunch of stuff.
Will they work in Linux and Mono or something?
Yeah, so I've tried it with MySQL, but there's for Postgres as well. It seems to work fine. I haven't put it in production, so it's pretty nice. And these type providers are great. And I don't know if anybody, you were probably listening to also to this machine learning stuff. There's a type provider for R. So if you're using the R language to do statistics and machine learning, you can just, with one line, you can import basically anything you can do in R into Fsharp. And you can use Fsharp language and write typesafe Fsharp, and it will then run R for you in the background to do visualizations and statistics and do all the stuff. So that's also a pretty nice thing. Another thing is, for those doing BI, there's this new, well, fairly new thing called BI-ML, which is BI modeling language, which is now being sort of hyped up. It's basically for doing ETL, SSIS and stuff, where you can actually script it with a sort of simple XML format meant for human consumption. I personally think XML sucks in all its forms. I think it's absolutely horrid to read, and it's bad for machines to read, and it's bad for humans to read, but that's my opinion. But I have created, if you go on my GitHub, there's an FS BIML, where I've done a complete combinator library for you generating the BIML XML files from the same type of combinator functions that you saw here. So you can write all of your BI ETL stuff in Fsharp and use all the functions that you have and all the tools in Fsharp to generate these XML files, and then just feed it to Visual Studio, and it will generate all the SQL files and everything to set things up. So that's pretty nice. We've been using that for a few weeks now back home.
Can we run these Fsharp codes directly in Power BI?
Not directly, no.
Uh-huh.
Well, I don't know. I mean, I'm not an expert in Power BI, but I don't know if you can write plugins for Power BI in .NET, because if you can do .NET, you can just write Fsharp. And I mean, you can do Office, all types of Office plugins, both for Excel and Word and stuff in Fsharp.
All right, okay.
So anywhere we can do .NET, whatever it is, you can. So there's nothing you can do in C# that you can't do in Fsharp.
We'll have the next session in a few minutes' time.